Kia ora tātou, it's Bill here. I want to look at this LDR, which I've got connected to pin number 3, my analog pin number 3, C.3. It's in a voltage divider, simple little voltage divider. I'll just show you the wiring for this. Let's have a look here on this. So what I've got is I've got the LDR on C3. Again, in the simulator, I can just change the values to represent a change in light level or lux. It's actually wired up in this diagram. You can see how I've got the voltage divider set up. The LDR goes to 0 volts, the other resistor goes to 5 volts, and that goes to C.3. What I want to do is I want to be able to detect sudden change in light, and I might use this then as a detector for someone who might pass a sensor, so that I know that a person has gone past the sensor and they've caused a shadow to fall over it. And what I'm going to do there is I'm going to keep a number of readings, and then I'm going to average those, and I'm going to look at playing them with a bit of statistics to see if I can figure out a good way of monitoring that. So let's say I'm keeping 16 values over time. So I've got an array which is split up into 16 different values. I'm storing unsigned 16-bit ints into my array. I've got a main function. Let's have a look at this. The first one reads the LDR and then sends it out to my TeraTune, my serial port. And then I store the light reading. So if I go down to store light reading, here's the function here. I'm passing it the unsigned 16-bit value for the light reading itself, just a raw ADC value, and then I'm storing it, I'm passing this pointer to an array. Now, what I'm doing then is I'm looking to see what the value of this variable pos is, and that will determine whereabouts in the array it's stored. So if I have a look at TeraTune, which is running here at the moment, it's got the first value is the value that's been read in, and the next 16 values are the values stored in the array. So that's how I've got this set up at the moment. Let me just reset this program by uploading it again, and you'll see that the first value 505 is read into and then stored, and then after that each value is stored subsequently in the array. So what I've got going on here is the first value goes into the first location, the second, the third, fourth, fifth, all the way down to the 16th value. So whereabouts are we at the moment? We're around here somewhere. So 197 is coming in, and you'll see I got 505 here. So this is the 16th value on the end. Well, that one's about to be overwritten by the next value. So there it is, 196 came in and overwrote this value, and then the next value here. So 1, 2, 3, or 16, then the 17th, 18th, 19th, 20, 32, 33, 34. It will just continue to overwrite this array. And then we can do some mean testing and some stats on this. So I've got some stats I'll do. First of all, I want to look at the mean. Depending on whether I'm talking about the population mean or a sample mean, so a sample of the population, will depend on how I write the formula. So, you know, it's mu equals the sum of these values over n, and the sample mean is just the same calculation, but we just give it a different symbol. So there we go, the sum of the values over n. Now what I'm going to look there for then is I could just look to see if my next value is different to the mean, and how different it is. So I'm actually printing the mean out. You can see the mean is 200 here. And so when I cast a shadow over this, you'll see that 463 came in, 473, and you can see the mean is different. Although the mean will start to move as because of these new values slowly filling up the array, as you can see. So let's just take my hand away again. We got those values around 200 or so, which are just going to populate my array again, and my mean will go back down to 0. A tidier way of looking at this is actually to look at you know, the spread of this range of numbers, and then compare the new value that's coming in to that spread to see where it lies. And of course, now we're starting to talk about things like standard deviation and a thing called a Z-score. So basically the standard deviation is calculated fairly simply, depending again whether we're talking about a population or we're talking about just a sample of a population. So here we've got a standard deviation of a full population, which is, this is a bit untidy. So there's your mean coming in there. So each value subtracted from the mean and then is squared. And then the sum of them is kept, and then we divide by the number of samples. If we're only looking at a sample of a full population, it's subtly different. This standard deviation is called S for a sample. And again, it's the square root, though, of the sum of each individual value's difference to the mean. Again, we just use the mean for a sample rather than the population. And we square those, and we subtract n over -1. So that's the big difference here between these two. What I'm really interested, though, is I'm really interested in something called a Z-score. Now, the standard deviation is really, it's the spread of the data relative to the mean. So what I really want is I want some value which gives me how many sort of standard deviations my new value is from the mean, and that's the Z-score. So the Z-score is the number of standard deviations above or below the mean. And so what I'm looking at here to do this calculation is something that's just really straightforward maths, depending, of course, whether you're talking about the population or whether you're talking about a sample of the population, is just how it's written. So we're going to do this calculation in the program, and that's what I'm doing at the moment. If you have a look at the data coming out, you can see the mean, and then after that you can see the standard deviation. And there's the next value is the Z-score, the difference in value between what we've got and this new value that's coming in. So the number of standard deviations, the new value is away from the mean. So just those values, they're all coming in around low 200s at the moment. So just wait for those to trickle through. You can see that the Z-score will be slowly coming down. And the Z-score, well, actually what we've got, once we've got a really tight number of samples, it's really easy to get quite a reasonable size Z-score. You know, these values, 207, everything's fairly constant at the moment. Clouds outside have come over, so our values are slightly higher now than they were previously, around 190. But if I make a sudden change to this, then what happens is that my Z-score just changes, 3.87. So, you know, there was this huge difference, and you can see that value 511 now trickling through the array. Well, all the other new values trickling through the array, and ultimately it will overwrite that value. So it's quite a nice way of just seeing whether we've got a rapid change in light level. So we'll be looking for something probably around, you know, 2 or maybe higher. Just depends on what sort of values we're getting. Now that was only 1.42, so, you know, because I've done this a number of times, the shadows have gone past, the spread has changed. So if we wait for it to stabilize again, wait for these values to all trickle through our 16 values in the array, then we'll find that we can get a new shadow will actually make quite a significant difference. So we're just waiting for those last top ones. We've got some numbers around 400 and something, which has slowly been overwritten. Just a couple more at the top to overwrite, one more. And now we've got all our values all around this, sort of hovering around 200. So a shadow will cast quite a big change. So there it is, 3.86. So that's our Z-score. And this gives us an indication that the light level has changed rapidly. You could use this test to determine whether someone had approached this sensor, or even If you were monitoring light level over the period of a day to see if you wanted to detect when it was night, then you could use this in the opposite way so that you could ignore sudden changes, but only monitor long-term changes. There's a little bit of interesting way of looking at our readings. If the next video, I'm going to have a look at this code in detail and have a look at some parameters and stuff. Cheers, hope that's interesting.